Hey kiddos, today we're going to be talking about the effects of changing dimensions on perimeter and area. This is actually not number 38, this is actually number 39. Okay, so first here we need to find the perimeter of this parallelogram, and we're given sides of 7 and 5. So the length's 7, the widths are 5. So if I write that in, to find the perimeter, we just basically add all those values together, and we get a perimeter of 24 inches. So we're going to complete this box here. So the original perimeter, 24 inches, okay? And we're going to make a few changes. So here we're going to change the width to twice as long. So the new width will become 10, and we're going to also change the length, make it twice as long, so the new length would be 14. So the new perimeter formula would basically be 10 plus 14 plus 10 plus 14, which means the perimeter is 48 inches. Okay, let's look at the next one. Original, again, was the 24 inches. This time we're going to make the width 3 times as long. So 5 times 3 gives me, the new width would be 15. The new length would be 7 times 3, which is 21. So we're going to write this formula out, would be 15 plus 21 plus 15 plus 21. And we would end up with 72 inches as the new perimeter. Alright, following the next one, we got 24 inches the original. Now we're going 4 times as long. So that was 5 times 4 gives me 20. 7 times 4 gives me 28. So the formula would basically be adding up those 4 sides. So 20 plus 28 plus 20 plus 28. And we end up with a perimeter of 96 inches. Okay, and the next one here, again, original is 24. We're going half as long, so half of 5, give us a decimal, 2.5. And then half as long as 7, it's also going to be a decimal, 3.5. So when I write this out, we have 2.5 plus 3.5 plus 2.5 plus 3.5. When we add that all up together, we get a perimeter of 12 inches. So, what conjecture can you make regarding the effect of changing dimensions on a perimeter? So, comparing it to the original and how it was changed, what can you basically say about it? Well, hopefully what you notice here is if I look at the original, and we changed the width and the length by twice as long. If I take the original perimeter and multiply it by 2, I get 48. Let's see what happens for the next one. Here we did 3 times as long. So if I take 24 times 3, I get, 72. So notice here's a pattern here. We changed the width and the length by 4 times. So if I do 24 times 4, you get 96. And the same thing happens here. If I take half, because we changed the dimensions here by half, so I take half of 24, you get 12. So however the sides are changed, the same occurs to its perimeter. So if each dimension of a rectangle is multiplied by 5, what happens to the perimeter? Well, it's 5 times bigger than the original. Perimeter. Alright, this next part, make a hypothesis of what you think was going to happen to the area. Do you think the same thing that happens to the perimeter will happen to the area? Give me a hypothesis and you'll come back to check if this is correct later. So, what if the different dimensions aren't changed by the same factor for perimeter? Notice all of them, we always change the width and the length the exact same way. So, you really can't say anything in general about the change in perimeter. You would actually have to calculate it for each example. So there are no rules. There's no pattern when you say, change the width by, make it twice as big, but then make the length half smaller. So there are no rules about that. So generally, you would actually have to calculate it for each example. So you'd actually have to plug in some numbers and see what you would actually get if the dimensions are changed by different factors. All right, let's move on to area now. So now I have a different parallelogram here with a length of 8 and a width of 4, and we need to find the area of it. Now, the area is pretty simple. It's just base times height. So in this case, it would be 8 times 4, so we would get 32 inches squared. Remember, when we're talking about area, the ending will be whatever the measurement is, or units, and it'll be squared, okay? So the original area then for this parallelogram is going to be 32 inches squared. So now we're going to work with a few changes here and see what we get for the new area, okay, and see if we can figure anything out. So the change in the width is twice as long, so 4 times 2 gives me 8. The change in the length is also twice as long, so that would be 16. So the formula is still base times height here, or sorry, same thing as length times width, same thing. So we would have 8 times 16, and 8 times 16 results in a new area of 128 inches squared. All right, let's move on to the next one. The change in the width, okay, it stays the same. So that's going to just be 4. But the length is 3 times longer. So 8 times 3, 24. To get our new formula, our new area formula, we would just do 4 times that 24. And that results in 96 inches squared for the new area. All right, next, we got 4 times as long, so the width is 4 times longer, so that would give me 16. And the length is half as long, so half of 8 is 4. So my new area formula would be 16 times 4. And when I do that, we get 64 inches squared. All right, and then the last one here, we're going to go with 1/4 as long. So 4 times 1/4 results in a width of 1. And we're going to make the length twice as long, which gives us 16. So the new area formula would be 1 times 16, which is 16 inches squared. So, what conjecture can you make regarding the effect of changing dimensions in area? Well, let's see, how can we compare them? 32, if we just do, both of these are the same, they're twice as long, so if we just do 32 times 2, no, that doesn't give us 128. It only gives us, what, 64? So how do we get to 128? Oh, you may have to consider the other two. Oh, so it looks like what the pattern here is if you take the original area and you multiply it by the two different changes, or even if the changes are the same, but you still have to multiply by those two changes, then you get the new one. So for example, if you do 32 times twice as long, which is 2, times twice as long, which is 2, you end up with 128. Let's see if that applies for this next one. So the original is 32 times the first change stays the same. So that's basically like times 1. And then the last one here is 3 times as long. So if I times that by 3, yes, we get 96. Let's check again. 32, because that's the original area, times 4 times long, so that's times 4, times here, which is half as long, which I'm going to multiply that by 0.5, and I get 64 inches squared. Yes. So, the conjecture that you can basically make is, so basically, you take the original area, you multiply it by the first change, and then you multiply it by the second change, and that'll give you your new area. Alright, so for this first example, we have the area of a trapezoid is 34 inches squared. What is the new area of the trapezoid if the height were doubled and the bases decreased by 1/3? So essentially all we have to do here is take the original, which is 34, and we're going to multiply it by the first change and then multiply it by the second change. So here are my numbers, and if we work that out, we would get a new area of 22.7 inches squared. This next one is an OYO problem, okay? Very similar to the previous, so make sure you jot this part down right here. So this last question is summing it all up together, okay? If the dimensions of a rectangle are doubled, which of the following are true about the effect on the rectangle? So what we have to consider here are our rules. We know for perimeter, all we had to do is take the original perimeter and multiply it by the change. Just one change, basically, because the perimeter usually change the same. The area, though, we would take the original area and you'd multiply it by how one of the things changed, and then also multiply it again by how the other item changed. So, if the dimensions of a rectangle are doubled, okay, that means we're multiplying it by 2. So the remainder would be 2 times bigger. But here for the area would be times 2 times 2, which would actually lead it to be 4 times bigger. So the new area will be 2 times. That's not right. The new perimeter, though, will be 2 times. That is correct. That was correct. The new area will be 4 times, and that one's also correct. The new perimeter will be 4 times. That's a no-go. Alright, so that kind of sums up the effects of changes.